All right, you should be able to sign the rule. Okay, what else? I did post. John Robinson. About another minute, we'll start. Make sure you sign the rule. All right. Anybody have any questions about the notes, chapter 5 that we've been over so far? We basically went over the while loop and plus plus and minus minus operators. Anybody have any questions about those? Okay. Questions? All right. So we stopped at the do while. All right, we kind of looked at it a little. The do while loop is a post test loop. All right. Remember the while loop, you had to test a variable or value to see if you can go into and execute a statement or a series of statements. But the do while loop will allow you to perform the statements first, at least one time, and then question you as to whether or not something is greater than, less than, not equal to, whatever. All right. So if we look at our online GDB, just take a while loop. It would do int x equals 0. All right. And we say while x is less than 5. All right. This is a while loop. And we could say cout okay, and in L. And then I'll do x plus plus. You got to remember the plus plus. So this is a while loop. So what it means, a while loop is a pretest in that you have to test this expression to see if it's true before it can perform this. So this has to be done prior to this being executed. So if I run it, oh no, I got an error here. Okay, stop this. Okay. All right, so if I run this, all right, it should output BRCC 5 times, okay? Running a little slow. 1, 2, 3, 4, 5, all right? The while loop, the do while loop, on the other hand, remember we could take this, you know, it's pretty much, you have the same setup, but I'm gonna cut this and I'm gonna paste this here. This is the format, and I'll replace this with do. But you have to remember, you have to put a semicolon at the end of your do statement. All right, so do, well, you got your x equals 0, that's your starting point. This is your test condition. This is your increment. So what happens here, it says x equals 0. So we're gonna actually perform this. There's no test being done. That's why it says a post-test loop. It's gonna output BRCC, all right? Then increment by 1. Then it's gonna ask if 1 is greater than 5. 1 is not, well, if 1 is less than 5, it is. It's performed. It's 2 less than 5, performed. 3 less than 5, 4 less than 5, 5 less than 5. So it's gonna perform 5 times. All right, so when we run this, we should get what? 1, 2, 3, 4, and 5. All right, so this is the format of a do while. And normally your do while loops are good when you actually, and we'll get to it later on in the chapter today, menus. Because normally with a menu, you want to actually print out that menu. You want to prompt it and then ask them if they want to make a choice from the menu. All right. So we go back to the notes. It said the do while loop sometimes looks something like an inverted while loop. Right. So it says, let me remove the. Well, here is the do while. And like I said, you got do, but then you got your curly braces and your closed curly braces, and whatever statement or statements goes in here, and this your expression semicolon. All right. So here's another example: do curly brace. All of the statements that you want could have ifs in it, could have while, you could have a call for a function, whatever. And then your while loop or your while and your expression semicolon, all right? And it says it's a post-test loop, which we talked about. See, the while loop is a pretest. If x is never less than 0, it'll never perform this. With a do while though, x could be 1,000, all right? It will perform this first and then ask the question. All right, so that's the only difference between a do while and a while loop. One is a pretest, one is post-test. And here are some examples of a do. It's same example. You got like where you're reading in 3 test scores and getting the average. So what happens here is your variables are declared, but what? We will at least perform the calculation of getting the average, getting the numbers and the average at least once. Once we do that, then it's prompting us, asking us if we want to get another average. So it will actually perform it one time and then continue if we say yes. If not, it's gonna kick out. So see the purpose of the while, a do while. All right, using a do while with menus. Okay, and what I can do, I think I've shown you before, but let's go to online GDB and let me go to my projects and I'll open up my menu. I'll open this up. All right. So, and I showed you this before. What happens is I have a menu here. All right. This is a program. Let me minimize it a little bit. All right. All right. So this is a program where it allows you to input 2 numbers. Once you input 2 numbers, then it prompts you with a menu. All right. It prompts you with a menu. All right. But then I have if, or if. But with this menu, I can make it perform this menu multiple times if I do and then say, wow, you know, here I could say, and normally you don't want to put it that way. You could say do, open curly brace. All right. I'll take this and I can tab this over and then I'll do close curly brace. All right. So what I can do here, I can have this do where to actually perform this at least one time. All right. So now what I'll do, I could leave all this in. Well, I'll show you to do this. And I'll say, okay, inside this do, I'll say, wow, CH, not, if I could say it, not equal 1, or if I could type OCA, well, I'll say 1, because that's a char value. Can I make it integer? Right. Let's make it integer, and that'll make it that'll allow it to me to do a number range. Okay. Okay. All right. So now, so what I can do here, I can say, while CH is less than 1, or CH greater than 5. So what happens here is this little small part here, it will not check any of this until this holds true. And I put a semicolon here. So what happens? My menu is displayed. I'm doing this. It said, and then it say enter a choice. If I enter 0, 0 is less than, is 0 less true? 0 is less than 1. So that means it'll go back up here and put this menu. Now, like I say, I could put an error message saying, please input the proper number or whatever, but I'll just leave it like this and show you how it runs. All right. So what happens is it's going to stay stuck on the menu until I enter a valid number. All right. So do, all right, enter the first number, 10, enter the second number, 5. So like I say here, valid numbers are 1 through 5. All right. I'll put in 10. See, well, come on. I think it's slow. Right. See what happens? It gives me the menu again. It's like I put in an incorrect value. It's not letting me continue on with the program. I'll put in -4. A backspace. Or did I? No. See? -4. So I have 10, which was invalid, -4, which was invalid, and now it's still prompting me. Now, if I wanted to just clear the screen each time and just let my menu prompt up, I could have put my clear screen at the beginning of this loop, and it would clear the screen. So the do, like I said, it will not let me continue until I enter a valid value. So I'll put in 1. So 10 and 4 is 14, plus 4 is 14. Whoa, wait. Oh, I did R. But no, if either side is full, that's right. What happened? If it's less than 1, okay, no, that's true. It equal to 1. So it should kick out true or wait a minute, my logic. So our choice is less than 1 or greater than that. That's right. True or false? True and true, right? But if it's 1, oh, yeah, I see what it's saying. It should do that with R. No, I got my logic wrong again. I did it the same like last time. Stop it. If choice is less than 1, but this shouldn't work. Because if I put in -1, see, it's gonna run. So it gotta be R, but why is it going? Hold up, class, I gotta get this straight. Stop. I stopped it. All right, I'm excluding the range. All right, so if it's 1, this side will be true, and this side will be false, but then that means it will continue. Okay. So that still will be true, even if, because this side will be true, and no, that would be false. But 1 is, if it's 1 greater than 5, no. Is 1 less than 1? No. Is 1 greater than 5? No. See, that should be or false and false. It should kick out. So let me run it again. If choice is less than 1, say it says 2. Is 2 less than 1? No. Is 2 greater than 5? No. So it should kick out. That's false and false. So I'm gonna run it again. I'll see what happens. I'll say not negative. I'll say 4. I know. Oh, that's the numbers. All right. Menu. I'll say 4. Why is it going to the menu? It's 4. Oh, it's 4 less than 1. That's false. It's 4. It's 4 less than 1. That's false. Or 4 greater than 1. That's false. It should kick out. Unless I have. No. Choice is 4. It should do this. I'm gonna have to look at that logic, because let me see something. I'll have to look at that logic, but it should continue. Give me execute the function and then return back and display the menu. But it's not going for some reason. I'm entering. Oh, choice. Hey, my fault, class. CH will never be choice. That's the problem. So let me make this choice. Okay, I have choice here. I got choice. So that'll be choice. I won't change the program. So CH will never be choice. So I'm checking a value or a variable that's never being inputted. All right. I'm inputting choice, but I'm never inputting CH. So if I put in 3, so that I do that, and see how it went this time. Well, no, not my menu. If I put in 3, it should give me 8, right? Oh, what? No, multiply it. It would give me 15, and then it exited. So I was reading in CH when I was I was reading in choice while I was checking for CH. So that was my issue. And sometimes we have that issue, like I say, when you're checking a variable, but the variable that you're inputting is not the right one. So that do while will perform, okay, until I put in a valid -1 and 4, that'll give me 3. All right, so if I put in 9, click here, I put in 9, where we at? Okay, something wrong. It's slow. What's wrong? Come on, computer. All right, I'll put in 9. Computer slow. Something happening. Oh, wait on it. It's running slow for some reason. Let me stop it and run it again. All right, run it. Wow. That's the updating the system. All right, I'll put in 9. Wow. Come on. Stop. For whatever reason, now the system running slow. Okay, enter the first number, 6, 7 and 7. All right, put in 8. Okay, 8 is invalid. Put in 10. 10 is invalid. Put in 4. All right, 7 and 8, that's 56. Well, 7 divided by 7 is 1. All right, so now it's working. All right, so let's go back to the notes. So what happens in this program, it will do, what it's gonna do, is gonna display this menu first without having to ask or test for anything. And then you would make your choice as to which operation you wanna perform. So I wanna, whether it's adult membership, child membership, or senior citizen membership, or simply to exit, okay? And based on your answer, you can perform any one of those. All right. So let's also talk about with the case statement. All right, they use the case here. I could have used the case statement in the program, and if we must stop this if it's not already stopped. It should be stopped. Yeah. All right. What happens? I have the if logic for my case. All right, but for my menu, but I could have case logic here. So I could take all this logic from here, which I had put in previously. I could stop it. All right. This switch, I'll copy. And wherever my if logic is, I'll take this and put here. And what it does, it's kind of, you won't have all those levels, and I'll do a paste. So all of a sudden now I have this do, all right, which displays this menu. But then what? Case, if it's A, do something. If it's B, I mean 1, perform whatever. If it's 2, perform whatever. If it's 3, perform whatever. But notice after each one, I have my break. All right. And remember we talked about the break where if I was checking for the little a and the uppercase A, I probably wouldn't put a break here. I would have the case little a colon, case uppercase a colon, and then whatever I want to do if they inputted that letter in. All right. So the break allows you to break out of the case. But if you don't put a break, if I chose number 1 and I don't have a break after this, it would perform case the logic for case 1 and case 2. So you got to remember that until it see a break, it's gonna fall in there and perform. All right. So that's what they're talking about using menus. All right. So once you learn the menus, you'll be the case logic with the menus, you'll be, pretty much set. Now, there's another loop called the for loop. So we went over the while loop. We went over the do while loop. The while loop is a pre-test loop. The do while loop is a post-test loop. But our for loop, it normally allows us to perform a loop X number of times. We can tell it how many times to perform it. We can do it with the other loops, but this one somewhat is an easier way to write it, to perform it. Let me see. I think I was on 2.7 or something. I don't. Let's see. Nope, that's 4. I don't know what I did. Not 6, 5. All right. Still in 4. All right. So let me. Am I here? Okay. The for loop. So, like I said, the for loop. What happens is you have the same properties as a while loop and a do while, but it's set up a little different. All right. It's set up a little bit different. All right. So with the for loop, and this is page what, 278. With that loop, I'll show you. I'll go to online GEDB. Now, with that loop, I'll take all of this out. Well, let's say we just do a new one.
You just confirm what you just said, Mr. Sylvester. You said
what's that?
Like there was some like pre and post test like different loops that you can make, and so depending on like what exactly you need, that kind of depends on which way you go with it as far as choosing your loop. Like there's a best choice for a loop.
Yes, there is. Right, there is. Okay. And with the for loop, you can specify a number of times, and you can do it all in that one statement. Whereas with a while loop or do while, you got your initialization before the loop or wherever. Then you got your increment within the loop, and then you got your test condition in that while. All right.
So right. So not only do you just see like, okay, this is for that, but you can look at the actual characters, the syntax, and determine that, okay, this is what's happening. Is that
right? How many times it will perform? That's right. Okay, yeah. That. Right. So watch. If I do something like this, if I tell you I wanted you to perform a loop, write a loop that will perform 10 times. You know you want to do it 10 times, so you can use a for loop. So you can say for, get this out of the way, and then int. Now, x equals 0, x less than 10, x plus plus. So what this is saying, my starting point is what? 0. I'm going up till what? Up until 9, not greater than, not equal to 10. So 0 through 9 is what? 10. And I'm incrementing by what? 1. So everything is what? In that line, so you can do whatever you need to do. And like I said, I normally want you to put the curly braces until you get comfortable, because what? With a for loop, the next line is by default is the line that it will execute. Now, what you're saying, what I mean by that is, I could say cout BRCC, right? I could do this, and this is totally fine. it's going to output BRCC how many times?
10 times.
10 times. Now, the problem comes if I say, okay, I want to output BRCC, and then I want to output Baton Rouge. All right. Now, what happens here? What's going to happen if I execute this? It output BRCC 10 times, then which going to complete the loop, then it's going to output Baton Rouge. So you see how it can look confusing, right? So if you,
Can you say that one more time? I had to adjust something.
Okay, what I was saying is, this logic here will output BRCC 10 times and then continue on with the program, which will output Baton Rouge. Let me show you. I'm going to run it.
Oh, yeah, because you don't have your brackets.
Right, and that's why. And see, the brackets are not necessary, but when you start putting the brackets, you can actually understand what your program is doing a little bit better. You got me what I'm saying? Until you get more proficient. Like now here, I'm going to do all of this how many times?
Everything's going to be 10.
10 times, correct. So see how it just makes it more understandable. So now when I do control, when I run this, I'll get Baton Rouge BRCC, Baton Rouge BRCC, Baton Rouge BRCC 10 times. See? So I got each one 10 times. But that may not be what you want. You may want to do what? Just BRCC, right?
Right.
So now this will print BRCC 10 times and then Baton Rouge. So I'm just saying, the way I did it at this point with the curly brackets or without, you'll get that same result, but it could be somewhat confusing when you're trying to write code and you're like, man, I don't know why it's not adding this number. It's doing it. I told it to do this 10 times and it's not doing whatever. It could be because of your curly braces. You didn't include it in the process, in that loop process, all right? So, like I said, you got your initialization, right? Then you got your starting point, and then you got your increment. Now, I think I said it before. It doesn't matter where you start counting from if you're not using the counter in some type of expression, all right? What I mean by that, I can start X at 100 and go to what? Less than 110. I'm still performing a loop how many times?
10.
10 times. So it does not matter as long as I'm not doing something with X and influencing X to change a value. And when I come back up here, X is a different value. You understand?
Right.
But as long as you saying, okay, X is just my counter that I'm using to iterate 10 times, you could start from 100 and go to 90. Well, equal 100 and greater than 90. All right, but I'm gonna have to do what? Minus, because now what? I'm starting at a high point at 100 and I'm going down to greater than 90. So you understand? So it's all in your, and what I said. Many people, when you take a math class, many people approach math problems differently because of the way they think. You know what I'm saying? So if somebody write a for loop to perform 10 times and they go from a negative 10 to greater than 0, nothing's wrong with that, right? If they go from 0 to less than 10, nothing's wrong with that. If they go from 1 to less than or equal to 10, right? Nothing's wrong with that. But you as the programmer, you have to keep in mind how you want to write, your logic. You got what I'm saying? So I could say 1, and then I could say what? Less than or equal to 10, correct?
Right.
Now, but I would tell you this: when you start working with arrays and vectors and dealing with character positions and whatnot, which is strings dealing with arrays, the computer always starts at 0.
Right.
So,
that's what I've been reading.
Right. So that's why many times when you see teachings of programming, they'll say, okay, let's go from 0 to less than 10. Because if you have an array of 10 numbers, the first number is in the array position sub-0.
Right.
You got what I'm saying? So that's why we do that. But to just do a loop 10 times ain't no problem. Now, and I'm gonna give you an example. This is kind of going advanced. I'll say string. I'll do pound include string. All right, string. Right. So what I'll do here, I'll just say, okay, string name. And what's your name, Mr. What? Marler?
Marler, yes, sir.
Name equals and M-A-L-E-R?
M-A-R-L-E-R.
Oh, M-A-R-L-E-R. Now, Mr. Marler, how many characters is in your name?
Total of 6.
6. So the first character is in what position?
Uppercase?
No, what position?
Oh, 0.
0 position, right? So what'll happen is I could say for x equals 0, right?
Right.
X less than the 6, correct?
Right.
And then I can do x plus plus. I can do this. I could say C out, and then I'll do. I could take this out. I could take all this out, and then I'll do name, and this is subscript sub x. Where what? The first time through x is what?
0.
Second time through x is
1.
Next time
2.
and 3, 4, 5, right? Because we don't want to get to 6, 0 through 5, right?
Right.
So you understand why we talk about 0 to whatever many times, or you see it in the code. Now, so when you look at this string, a string is an array of characters or series of characters. So if I asked you to print out name sub 2, what character would print out?
The lowercase r, the first
Correct. The first one. So watch. What I'm doing is I'm printing out each individual character on a what? New line, correct? Then I'm outputting Baton Rouge, correct?
Right.
So when I run this, what I got? Int, at my semicolon. All right, so now when I run this, see?
Right.
It took each individual character using an array, name which a string is an array. Name sub 0 is M. Mm-hmm. When X was 0. Name sub 1 is the A. It printed it out. Sub 2 printed it out. Sub 3 printed it out. Sub 4 printed it out. Sub 5 printed it out. Kicked out at 6 and printed out Baton Rouge. Right?
I'm tracking.
Right.
That's pretty interesting. It's just kind of mind-boggling just to see like where this could go with arrays, like what you could do with arrays.
Right, and see an array, you got one variable name that can hold X number of a particular data type. Because you could do an array of numbers. You understand? And give you an example. If I do say int X, not X, I'll say num, and I could do an implicit or explicit, but we know we're gonna do 6 because we're in that loop, and we'll be in that loop. And so I'll say 5. We got 5. Well, 5 numbers. No, it's 6, right? Now, and then I could initialize it, and I'll use curly braces, and I could say I'll put 1, 2, 3, 4, 5, all right, and 6, right? So now, if I do this, and I'll go here and I'll do, and I'll say num sub x. And I'll do num sub x. All right. Now, when I print out m, I'm gonna print out what? Num sub x. Num sub 0 is what?
Num sub 0 is 1.
Right. Num sub 1 is 2. Num sub 2 is 3. You understand? Mm-hmm. So when I run this, so you see here? So num is one variable that contains what? 6 different what? Integer values. So, but that's arrays. So that's just we kind of diverted. But that's why the for loop, would be good. Now you could use a while loop, but you have to set x equal to 0 at the top, and then inside do the plus plus and test to see if this is less than 6 or whatnot, right?
Right.
So you got those things. Now, with string data or character data, normally you could test for the end of the string or the length of the string. Like I could say for x equals 0, x less than string length of name. So it's all kind of things you can do to control the iteration. All right?
No, but I want to keep them.
Oh, all right. So that's loops. Right? Like I said, for loops. And like I said, talking about for loops, here what? For, count equals 0, count, which we did, we did 6. Count less than 5, count plus plus. This is valid. But remember I say, use the curly braces just to keep yourself, understanding what's going on where. But it'll print out hello what? 5 times, right? Now, we can still get infinite loops with a for loop, right? Because if we do something, well, I can't do it with arrays, I'm gonna get errors. Because you can go out of bounds, but your subscript goes out of bounds. Sometimes you'll get errors. But with a for loop, if I set x at 0 and say less than and perform till less than 6, and I put minus minus, I'm never what? Reaching what? 6. So I'm gonna be in an infinite loop. You got me? Or I can do something like this. Do something like while x is what's that? X is equal to 0, x greater than -1. See what? It's already greater than -1, so as it keep adding, it's just gonna keep going. You understand? It'll never stop. Okay? So you got to be careful. You got to be careful of your loops. Now, let me ask you this question. Less than 6. All right? And I got plus plus. If I do this inside this for loop, if I do x plus plus here, what end up happening?
It's then by 2.
It's gonna do what?
Oh, give me a second. It's since you're using x, since x is in your for loop as your variable, it's gonna add another 1 to that. And so not only is it being added in the increment spot, the first one, but it's gonna add a second one every time it runs. And so
which will cause
it'll only do half your loop, right?
Correct. There you go. So it's gonna print the first one. It's gonna it start out at 0, right? So it's gonna print name sub 0. It's gonna print num sub 0. Add 1, it becomes what? 1, right?
Right.
Add another one, it becomes 2. Then we're gonna print out name sub 2, right? And num sub 2. Add 1, it becomes 3. Go back up, add 1, become 4. You got what I'm saying? So it's cutting your loop in half.
Right.
All right. So when I run this, watch what happens. It's gonna print M, then skip the A, print the R. See here, M, skip the A, print the R, skip the L, print the E, and skip the last one. Right. So and normally, I wouldn't say this is 1, But what people do is, I'm gonna take the number off. Normally, you can kind of use some of these techniques to write encryptions. All right, because watch, I printed, and like I said, I printed Marla the first time, but watch what happens here. So we could take a name and cut it in half. Oh, what did I do? What did I do? What did I do? What did I do? See out. I missed my see out. Okay. So if I run this, say, oh no, I didn't want to do this part. I want to show you how it's going. It'll print out name sub X. That's what I want to print out. So when I run it now, I'm gonna get A M R and what did I do? Oh, semicolon again. All right, I'm gonna get M R and A. Yeah, E. You see what I'm saying?
Right.
M R E. All right. So sometimes they do encryptions where they do something with words. They'll scramble them, or they'll change them where they bump them up so many characters, or down so many characters, or stuff like that. You understand?
Right.
So that's some of the stuff. Yeah. So when you get to understand that, man, you're pretty good. So here, basically, it's saying the for loop. This is the initialization. This is the test, and this your increment. So that's your for loop. Start that count at 0. Long as it's less than 5, we performing our whatever increment. Performing whatever increment. Performing whatever increment. Then when it gets greater than 5, we kick it out. Or 5 or greater, it kicks out. So the loop's basically the same way. It performs the same way. But like I say, with the for loop, you can tell it how many times you want to perform it a little bit easier than the other way, because you got a specific number of times you want to execute it. And I think this was a program that you typed at the beginning of the semester dealing with doubling a number or squaring a number. And y'all just typed that one in from an example. All right. So what happened here, it did a for loop. But now look what they did here. We use in our program what? An actual number, right? We use what? 0, and we use what? 6. This our starting point. This our ending point. Now, what they did in the book, they did something like this. Const int min value equals 0. All right. Then const int max val equals 6. All right. So those are constant values that can't be changed. So rather than do 0, I could do what? Min val, if I could type it right. And then here I could do max val. So what? And we as a programmer know that min val is what? 0.
Right. Max
val is 6. So you see how you can write your program to be more versatile. So what? If I'm dealing with something, some type of array that I know is a certain length, every time I do a for loop to process that information, I could use my max and I could use my let's do it right. I can use my max val and I can use my min val rather than what mistakenly type in 5 for 6 or whatever. And then also, if anything changes in my with the length of my string or whatever, I could just go up here and change my size here, and it's automatically done throughout the program. So those are some of the advantages of using variables. All right. So that's all they did here. Use a min num and max num, and then in a for loop, min num, num less than min num. I mean equal min num, num less than or equal to max num, and then they performed it. All right. And like I say, basically the same thing. Your min num is an initialized expression where its num is equal to min num. Here is your expression where num is less than or equal to the max num, and then you incrementing by num. All right, num or num, which is num plus by 1. All right. And basically the same exact thing where you assign min num and max num, but then you're saying what from min num equals 0, and then you're seeing if num is less than max num, less than equal to max num, display increment num. Is it less than max num? Display increment num. On and on till it becomes less greater than, and then you kick it out. All right. So, like I say, to determine which one to use. All right, it says you should use the for loop instead of the while or the do while in any situation that clearly requires an initialization. All right, okay, uses of false conditions to stop the loop and requires an update to occur at the end of each loop iteration. All right, and program 5.9 is a perfect example. It requires that num, like that the num variable be initialized to 1, and it stops the loop when it's greater than 10. So you know the iterations. So so that makes it a whole lot easier. All right, and it increments till it gets to the end of that loop. All right. So if you know how many times, just go ahead on and do the for loop. Now, well, let's look at this first before they show it. Looking in at here, like you got int num equal min num, while num is less than or equal to max num. So see how everything is pretty much the same, but it's in different places. Here, everything is all here. You got everything in place. You know how many times you're performing it, and what? You could have just that one statement, you're going. You don't have to what? See out something, then increment, then come back, but then also have another statement outside doing an initial or doing an assignment to that. Everything is done here, and then this is your output. But I would say do curly braces. So here we got 1, 2, and 3, 4, 5, 6. Here we have 1, 2, 3, 4. All right, if you do the curly braces. If not, you just have what? 2. All right. As you get better, you can because that's why I would say if you're gonna have a for loop and you will not use curly braces, I would put space in between so you can see that that next line is the only line for that for loop. So you'll come up with techniques so that you'll understand, what's what. All right.
Is there ever going to be a point where we need to make a code without using the curly braces?
Well, yeah, because if you just had one line to perform, you could do it. Remember what I showed you here? If I had this program and the only thing I wanted to do was output the name. All right, I got the name in. Now I want to output each individual character of the name. Then I'm gonna output Baton Rouge. I could do that here, right? Because what? For x equal min value, which is 0, x less than max value, which is 6. So it's gonna say what? C out num sub 0. It's gonna go right back here, increment. See out num sub 1, increment. See out num sub 2, all the way to num sub 5, and then it go kick out. Then it'll print Baton Rouge. So it's hard to answer a question like you ask in that every time you write code, it depends on the situation, what is being required. You understand what I'm saying? So sometimes you might have code to where, hey, man, I just need to, I'll say like this, I'll do this. I'm gonna print out Marla, the whole Marla, right? I'm gonna print out, I'm gonna just do C out name. And see, this is the beauty of strings. I could just do C out name and it's gonna print out what? The entire array, right? That's with character. I can't do that with numeric arrays. I gotta print each individual number. But with character well, string array, with string, I could just print out the number, the variable. But like say here, if I said here I wanted to output
is it possible to pull from like a mixed, like both character and num? You just have to do it one at a time?
Well, now you're talking about, can I have an array that has numbers and characters in it, but the one of them is numbers and one of them is character? No.
Not possible, okay.
An array has to be all of one data type.
Okay.
Now,
are we going to do that in this class or no?
No, that's going to be in 194. Now, in 194, when I teach it, what I give a program dealing with arrays, and then as we go along, you're going to see where we'd have string arrays. Because I tell you, read in name, read in maybe a number, like say an amount, read in a integer, so a double, a float. And what happens is, it's called parallel array processing. If I have 10 names, those 10 names, each one of those names gonna have an amount. So I have a string array of 10, a double array of 10, and an int array of 10. You got me? Now, when I look at name sub 3, I should also be looking at amount sub 3. And maybe the other value, the int value, could be age sub 3. All those refer to that one person. It's kind of like looking at a spreadsheet. When you look at a spreadsheet and you see like a record going across, a person's name, age, GPA, whatever. Then you see the next person's name, age, GPA, whatever. You look at that as an array. Because what? The first line, which would be 0 in computer science, that would be the first row. Got me? Name sub 0. Then the second one could be tuition sub 0. Then depending on going down 1, 2, 3, 4, 5, whatever.
And all that data would be captured under that person's name or whatever we had.
No, what happens is when you're dealing with parallel arrays, you're dealing with the subscript, because the name array gonna have 10 names, and then we just dealing with 10. You could have 100, 1,000, or whatever. But name array gonna have 10 names. Amount array gonna have 10 amounts. Age array gonna have 10 ages. But like I say, name sub 3 correlates with amount sub 3 and age sub 3. Say like if you was that third element in the those arrays. Your name should be in that third element of name. Your GPA or your amount should be in the third element of amount, and your age should be into that third element of age. So when I process using loops, then I can do what? For x equals 0, x less than whatever, print out name sub 0, name sub x, amount sub x, and age sub x. Go to the next one. Name sub x, amount sub x, and age sub x.
So
you got it?
Could you translate that to like a real world problem real quick? Like
okay, well, just take it like the class. If I wanted to write a program where I can input the class, you all's names, right, along with your test score or your test average, and whether or not you're a junior or senior, right? Depending on the size of my class, I'd have to make my array at least that big or bigger. Right. I can make it bigger, it's no problem, but I need to make it at least that large. So if you were the first person I'm reading in, I'll read in name sub 0, it'll read in Marla. Then I'll read in GPA, test average sub 0. Then I'll read in classification sub 0. Then I'll read the next person name in, whatever name sub 0, average sub 0. What else I said? The classification sub 0. I mean sub 1. Then I'll read in the next one, name sub 2, average sub 2, classification sub 2. So it's all being read in sequence where, it's like that. Now, the thing is, though, I give a program to where you have to sort the data. Now, you got parallel arrays. How many times have you ever sorted something in Excel and just sorted the row and not the entire data?
Right.
What happens?
I believe sometimes it'll like flip things around.
That's right. Because if you were Sub-Zero, but your name, your last name is Marla, when I alphabetized just the names and not the, well, not say alphabetize them, but if I put the names in alphabetical order, but not associate the GPA and the classification with that name, then all my data is out of whack. You could have somebody else GPA and whatever. So what we teach in that is how you have to do that parallel array processing. If I move array sub name Sub-Zero to name Sub-6, then I have to swap name Sub-6 with name Sub-Zero. But then if I do that, I'm gonna have to swap test average Sub-Zero with test average Sub-6. You understand? And then classification Sub-Zero with classification Sub-6. So so that what? When I finish, everybody still have the same information related to each other. And when I print out that record, name Sub-6, average Sub-6, and classification Sub-6, I get the right information.
Right.
Right.
I'm tracking now. I appreciate that. So
that's how that works. All right. But arrays, you got to have individual arrays for data types for each one. And each array has its own data type. Right. All right. So Mr. Robinson, I lost him. Mr. Robinson. Okay. So you said, like you asked about, will it ever be a time where you won't need the curly braces? Look at this. Say if I wanted to print out, and I'll just change this number here. We know that's 6, but let's change this to 20. This is going to allow me to print the asterisk 20 times. Notice I don't have a new line at the end. So it's just going to go all the way across the screen printing the asterisk 20 times. But what I'll do here, I'll just do something like this. So this can be separated. All right, so watch what happens. So see what happened? Now, I just got what? 1 asterisk. But what? It ran that loop how many times? 20 times. And then what? I could just take this loop here, all right?
At the bottom.
Right, I could copy it and paste it somewhere else, right? Also, I'll paste it right here. And so when I run this, so you see what I'm saying? Now, the only thing is I should have put a new line before that.
Pretty clever.
Right. So you don't have to keep putting asterisk, or whatever, or doing something. All right, so now print it. See, it automatically put that, and look, it's just a for loop. You got me? But I could have put the curly braces around this C out if I wanted to be comfortable, because I might want to add something else in between that. All right. So if I wanted to do this, all right, I'll see out that, and on the new line, I'll do something like see out. And I'm just showing you just some simple stuff that could happen. So when I run this, well, this one won't do that. It's gonna give me just 1 dash, right, Mr. Robinson?
Right.
Because if I want more than 1, I have to do what? Yeah, that curly brace, that's right. All right, all right. So now, watch. It's gonna be a set, see here? So see, I did this, and then Marla, which is the name. Well, I did this first, then I did the name, and then this single asterisk. So I'm saying it's just up to you as to decide how many times you want to iterate it, but also what all you want to perform with that for loop. If it's just 1 statement, no problem. All right, but I would say always put the curly braces so that you will not be confused. Just like when you do the if statement, same thing. All right? All right, and it says it's a pretest loop, meaning what? If it doesn't match, it won't fall in them, all right? Now, this is another thing with the for loop that you may not know, all right? Notice what I did here. I said int x equals, correct? Now, I could just say x equal, but if I do that, I have to make x, I'll have to do something like this. Int x equals 0 here, right? So now, but what happens here is, if I could have multiple lines of code before I get to this for loop, if x changed for any reason or I use x, x gonna be whatever that value is. So if for some reason I had code before this for loop and x was 3, then it'll go what? 3, 4, 5, and kick out at 6. You got me? So that's what I'm saying. So that's why normally you would want to put it or declare it inside there, so you know you're starting at 0 and ending at whatever. All right. So now another thing is, I could set x out here to 10, and I can still in here do int x, because what? Look here, int x. So you saying, Mrs. Weather, I got 3 separate x's in the same program. Correct. But what? This is the scope of the main. This is the scope of the for, this for, and this is the scope for this for. So you understand? Remember we kind of talked about scope? So as long as you use it within that scope, ain't no problem. All right? Okay. But if I chose to just take that int off of here, then the scope really changes. Now I'm dealing with the what? With x from where? I'm dealing with x of this, because I didn't do another initialization, correct?
Right,
So you got
global one.
Right. So you got to watch that. You got to watch. And that's just some precautions. That's all. I'm just showing you some precautions. So let's go back to the notes. All right. All right. So like I say here, what it's saying, this is wrong. No. Okay. Avoid modifying the counter variable. Remember we did that already, right? Because what happened if you increment here and increment here? You're doubling the loop, which doubling the value, which going to just perform the loop half the time. So you got to watch that. Not that you will get an error, it's just that your iterations will not be the amount of time that you want it to be. And notice it went from what? 1 to 10, or less than equal to 10, which is 10 times. All right? All right. Now, notice what? They started at 2, they ended at whatever, and what? Number equal num plus 2. All right? All right. You're not limited to use an increment statement in the update expression, okay? Here is a loop that displays all the even numbers from 2 through 100. So what? You can change this to where you can what? Jump that loop X number of times, all right? You could start here at whatever number you want. And remember, this is our test condition. So like I say, you can work with that. But like I say, you as the programmer, when you write code, you need to know what it is your program need to be doing. Because just to try to copy something from a book and not know what that code is doing, man, you could get yourself caught up real bad. All right. So looking at this one, here's the loop that counts backwards. Remember I said some people count from 0 to whatever. Some people may go from 100 to 110. Some may go from 0 to greater than 10. It all depends on the person, the way they think, you know. So here, this still will perform what? 10 times. You're starting at 10, well, 11 times. Because you're starting at 10, num is equal to 10, and then you're doing it till num is greater than or equal to 0. So this will perform what? 11. Well, let's say count down 10 to 0, but really that's 11. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. All right, so that's 11 times. All right, so you got to watch that. Defining a variable in the for loop initial. Well, we did this. Okay, int this equals this. All right, max that. Okay, so it said not only may a counter variable be initialized in the initialization expression. All right, it may be defined there as well. The following code shows an example. Okay, this is a modified version of the loop in the program, which is 5.9. It's got for int num equals min num less than or equal to max num, and num plus plus, and then we see out this, and then we doing the square, and then we doing the inline. All right. In this loop, num variable is both defined here, defined and initialized, which we did with X. All right. In this program, I think what they did, they followed. See, they just did num equal. So they was dealing with the what? The global value of num. In here, the scope of num would be within that for loop. Okay. So, but it depends, because sometimes, say you are manipulating string data, and to read in the data, you might have that local scope where you do int x equal whatever, x less than whatever. But if you had to create another loop to start reading, like say you had a sentence, and you had to start reading another part of once you reach a blank, read the second word, then you may not want to start at 0. Well, it depends. It just depends, But you want to start at whatever x left off at. You got me? So int x equal or y equals whatever, x equal y. Then say y less than equal to, not equal to a space, and you loop until then. Because that was a program. That's a good program to give. I give that one in 194 too, where you type in a sentence or type in a series of words, and then find the end of the words, and I tell them, or I do a name. I say, okay, take a name, first name and last name. Read in the name in one string. Print out the name. Then print out the last name, comma, nickname, and you have to input the nickname in all caps, and then the first name. So you're manipulating the string, whatever. All right, and it can be tedious, but it shows you how to manipulate using the loops and testing for whatever and whatnot. So that's why we teach you all this, so that when you get to that next level, you kind of understand loops, and you're like, okay, because thinking, that's the key point, critical thinking, and it's like you got to keep it on your mind. How do I go about doing this? Let me sit down with a pencil and paper and see if they gave it to me to write it out, what would be my steps? And then once you start tracking it and realizing, oh, I'm going to start here, but I need to know that value. Okay, the first position would be X, all right? So X is 0. Then I need to increment X till I get to a blank. Once I get to that blank, that's the ending. So now I need to mark that in. So, and stuff like that. So you know what's going on. Then once I get to the blank, if I'm at the blank, but I didn't go to the blank, I need to add 1 to jump to to that next character. So stuff like that, becomes important in how to process information. All right. So creating a user control loop. All right. So all this is allowing the user to input a starting and ending point. So what? All you're doing is what? Inputting the value for the start, inputting the value to stop. So like something like you might say, okay, say just the end. And like Mr. Marler asked the other day, how would you use it in the real world for a class? Say I wrote this program and said, okay, I want to input my students, their average and their classification. So when I do my loop and maybe doing the arrays, it might ask me, well, okay, how many students are in your class? Because it got to know how many times it's going to perform the loop. If I say 10, then I put in 10, and then what happens is when my loop starts, it's going to say, where's my for? For int, I could say num equals whatever, num equals 0, num less than or equal to number of students entered, num plus plus, and then it'll perform it that many times. All right, so that's all it's saying. You can input values. Or I could say, okay, I don't want to start at 0. I want to start at a certain number. So put in, well, what number do you want to start at? I put 5. Okay, what's your ending point? I'll put 8. So that means 5 less than 8, or if I do 5 less than or equal to 8, I could do that. Okay, because I could say for int num equals 5, but it'll be the inputted variable, all right, variable, and a num less than or equal to 8, num plus plus, all right? So it'll go 5, 6, 7, 8, which is 4 times. So it's just up to you how to write it, what is being required. So like I say, and there's many different scenarios, and you're gonna realize once you get on or start working on a job or with a company, some things gonna be similar, but most times your programs will never be exactly the same. And I'll give you an example. Just like in IT, you can install Microsoft Office or Microsoft Word application X number of times. But given the type system you're on, given the operating system used, given what all packages that you need to install, each install may be different, all right? So you can't always box yourself and say, oh, this is how it's done. I know the practical way of doing it, but based on the limitations and requirements, I have to cater to those things. So that's one thing to be aware of. Don't think inside the box. You got to think outside the box. All right. So as they using multiple statements in initialization and updating expression. All right. So here we got, look, int x and y. For x equal 1, y equals 1. All right. So what we doing here? Until we get to the semicolon, we doing what? We're initializing assigning a value to x, and we're assigning a value to y. Kind of like when we did doing, like say you do int x equal 1 comma y equals 1. Same difference, but it's saying for x equal 1, y equal 1. And look here, x less than or equal to 5, plus doing that plus plus. But then what happens? See out x, right? Then the plus, and then let's see out the value of y, and then put equal, and then you're doing x plus y. So what happens is you just actually giving the two values to start with, and then you're doing, but y is the counter. Y is the counter, not x. Y is the counter, right? But if we did something like x equal y, that could throw our program off, right? If we did something like x equal y somewhere right here, then what? If y end up being 6, then that would come back up here and kick us out the loop, right? So you gotta watch that.
What? I mean, I see it, but like, wouldn't it kind of just be easier just to throw in an additional variable, call it like counter or something? Like, you know what I mean?
For what? This is the counter though. X is the counter.
It is, but man,
and then you multiply, well, not you add x to y.
Right.
Right. Now, and like I tell you, it's what they're doing though. The book gives you these scenarios because, and showing you what you're allowed to do. You might not ever do it, but
okay.
you might say, man, I need to use the x. I need to go from this to this, but I need to add it so I can do something with it.
I was getting confused with like best practice, and so.
Oh no!
Excuse me.
But because see what it is, programming is so versatile, and what I mean by most times, and we do that with software. We learn what we want to know, the things that we need to know, and everything else we don't worry about. You know what I'm saying? But in programming, the more ways you know about doing things, how would I say it? The easier it would be to try to solve an issue, because like, oh, I know I can do this. Oh, I need to do such and such. And somebody else knows something. Oh, you could just do such, and you're like, man, I never knew I could do that. So it gives you those avenues to solve in different ways, right? All right. Totally. Because see what happens? X is 1 plus 1 to get 2. 2 plus 1 is 3. 3 plus 1 is 4. That's what the output of this will be, based on this, all right? So that's all it's doing, right? Just incrementing it or adding it, yep. All right, You can further modify the loop to execute two statements, all right, in the update expression, all right? Here's an example, X whatever, Y whatever. But look here, X is equal to 1, Y is equal to 1. X less than equal to 5, what? X plus plus, comma, Y plus plus. So see here, now what? X is being incremented the second time through, and Y being incremented the second time through. Because what? In this one, we only incremented what? X, right? So, and like I say, you may want to do it this way, you may not. It just depends. But say you had, you were dealing with two different arrays, because you don't have to be adding this, right? And like I said, a lot of this stuff, like I say, could go into encryption. And like I said, normally it's simple encryption. You throw the letters off by one position or whatever, or stuff like that or whatnot, or either bump it up so many characters. Because remember, the ASCII table, the letter A is 64, right? So if we add 3 to 64, we get what? 69, right? And we could store that 69 and then come back and take 69 and subtract 3, and we get back what? Our character, right? So that's how you can deal with that encryption and stuff, all right? Omit and loop expressions. Now, it tells you this can be tricky. You know, you can do it, but it can be tricky. But you have to know here what X is, what num is before you fall into here, all right? It'll take whatever num is, num less than whatever, right? You don't have to say num equal 1 because it's already known, right? But like I said, then it'll continue and perform the loop, all right? So now look at this one. It omitted what? The plus plus here and added it here. So man, it's just various ways. This here would work, but this will give you a what? Infinite loop. Because what? There's nothing to test. There's no variable or no value. So what? The program just gonna continue to perform this. So you're gonna have an infinite loop, all right? So you'd have to break out the program to stop it from printing hello world, all right? Because nothing is being incremented. All right. Keeping that running total. Now we talked about that, I think we did, but keeping that running total, if I go back to, not here, to online GDB, keeping a running total, what that is, you actually accumulate. Say we had a balance. What I'll do is I'll say, okay, I'll say float balance, okay? Now, and what I'll do is in here, I'll say, okay, see out. All right, so I'm gonna allow you to input your current balance, no semicolon. Input your current balance. All right, so we're gonna input the current balance, but then what we're gonna do is we're gonna allow you to input amounts, balance, and I'll say deposits, all right? And then we're gonna allow you to input deposits. So well, I'll do this like this. We talked about this. I'll say, I'll make this int number of deposits. So enter your bank balance and then see out number of deposits, all right? So I keep forgetting that semicolon. Kind of make it real world, okay? See out number of deposit. So now, all right, what we're going to do is we're going to say for int x equal, we'll start at 0. All right. Type x equals 0. X less than num deposits and x plus plus. So what happened? We're going to input our bank balance. Then we're going to say, okay, how many deposits? If I put 2, it's going to allow me to put 2 entries or two different amounts in because we're in this loop. But while we're in this loop, I need to do what? Accumulate my balance, right? Not overwrite my balance. I need to accumulate. When you accumulate a value, that means you're going to have it on both sides of the equal sign. So what I'll do here, I'll say cout. I need to do /t/n /t. Enter all right. And now I could do something like this. Deposit amount, and I'll do I could type number, and I'll put a space, and then I'll say cout. I don't want to confuse you. I'll do it like this. Oh no, it's the number of deposits. Okay. Nope, no. I'll just do x, y equals 0. All right, and then I'll say here a y plus y. But I could have started at 1. Yeah, I'll just do that. I'm confusing y'all, but I'll just start at 1 and less than or equal to, and then that way I don't need this. And I don't need this. And then I'll say number x, all right, and space. All right, so now, I have this. So see, I enter deposit, number 1, number 2, number 3, and then I'll say what? CN deposit. All right, when I input the deposit, now I have to say what? Balance, whatever I have for my balance is equal to, or I could do what? Remember this, plus equal, what that says? Balance is equal to balance plus whatever on that side, right? So we could use that, or we could just say equal balance plus deposits. And I know, okay. Now, so each time it goes through, it's going to increment my balance, increment the balance, because whatever deposit is, it's going to add it. And then I'll go out here and do cout. And then I can output balance. All right. Okay, so what happens is, what time class in? Oh man.
About 13 minutes ago.
Wow, I gotta do the file. All right, I'll just go over this and then I'll go over the file. So let's run this. what I have here? Oh, that's just Baton Rouge. I'll take this up. All right. So when I run this, hopefully I got all my errors out. You know, we got an error. What it says, see out. I got my see out directive the wrong way. See out right here. Okay. Hopefully that's all the error. All right. So in our balance, say I have $100. Oh, if I could type. Say $100, $100.50. All right. In a number of deposits, I'll say 2. All right. So see it say in a deposit, spell amount wrong, amount number 1. And so I'll say $25. All right. In a amount number 2. So see what happened? I'm caught in that loop, right? And that loop gonna perform at up and from 1 to equal to 2, from 1 to less than or equal to 2. So here I'll put in another $25. Hit enter, and see my bank balance is what? 150.50, right? So what happened is I entered my balance, which gonna be my occurring balance. It won't override because I got balance on both sides. I had a balance of 100. So when I got in here and it said I had 2 deposits, when the first time balance is equal to balance, 100 is equal to 100 plus 50. All right, I mean 25. Then 125 is equal to 125 plus 25. Well, 125 is equal to 125 plus 25, which gave me the 150 plus the 50 cent. I didn't say the 50 cent. All right. So you see what happens. All right. Questions. All right. That's your for loop. And that was a lot of stuff dealing with the for loop, whatever. Now, sentinel value. Sentinel value is just a value to end the program. You can have a loop and you can say, okay, perform that loop until I type in 99999. When you type in 99999 and hit it, oh, you're out. So it's a value that you come up with that normally is unique from any other value that's going to be inputted for that test condition. And when it sees that value, it kicks out. All right, kind of like a string. If I'm continually inputting string while choice is not equal yes. But when I put in 0, it exit out. It doesn't ask me for anything. I'm just gonna continue. Well, do you want to continue? Just continue. But when you put in 0, that string, it'll exit out. All right, so that's a sentinel value. Now, the engineering part, you want to make sure you're nested loops. Oh, I tell you, I want to give y'all a tip. Nested loops. All right, nested loops. Let's look at nested loops right quick. All right, we know about loops, right? But nested loops. A nested loop is a loop within a loop. All right. All that means is I'm gonna take all this out. All that means is I'm gonna perform a loop inside of a loop. So I have for int x equals, I'll put 5. I'm gonna just put some numbers so you can see what's going on. Say x equals 0. If I could type. X less than 5. All right, x plus plus. Then I'll say for int y equals 0. Y less than 3, y plus plus. And then I do something like this. All right. I want to ask this question. How many times will it print out Baton Rouge?
3 times, wouldn't it? Start
How
from
many?
0 to 1.
How many
2,
times?
3.
I have a nested loop now.
Oh, wait.
15
Only
maybe? Or 4
twice?
4 times 4 times 2, right? So 8 should be 8 times total.
Correct. What happens is we going from 0 to 5, 0 or less than 5. 0, 1, 2, 3, 4. It's gonna be 5 times 3.
Oh, okay.
Right?
Yeah, you're right.
Right. So that's 15 times. What happens is it starts at 0 on the outer loop. It falls in here, 0, 1, 2, 3, 4. 0, 1, 2, 3. Then it goes back, X becomes 1. Then Y starts over, 0, 1, 2, less than 3, right? Then it goes back out, Y becomes 2. So what? For every loop on the outside, I'm performing what? For every one of these, I'm performing 4 of these, 3 of these. Everybody see that? Everybody understand that?
Yes, sir.
So normally, if you got a loop within a loop, it's normally the max of this times the max of that. You understand? The maximum iterations of this loop times the maximum iterations of this. Because what's happening, I'm performing this loop, 4 times, 3 times, 0, 1, 2, right, 3 times, 5 times. If you understand what I just said. I'm performing this Y loop 3 times, 5 times. So for 0, 3 times. 1, 3 times. 2, 3 times. 3, 3 times. 4, 3 times. Kick out. Everybody got that?
Mm-hmm.
Okay. So that's our loop. That's our nested loop. Normally, nested loops, Mr. Marler, like this format, that is good for when you want to manipulate 2-dimensional arrays. You got me?
The first thing I'm doing is as I'm going to look up what these things look like in 3D space, so I can kind of get a better understanding of what's happening. Because you said 2D, like that's kind of what I'm thinking about, but I don't know exactly what you're talking about.
2D is just like a chart.
Right.
Take an Excel spreadsheet. You got rows, right? You got the number of rows, and then you got the columns. That's 2D.
Right.
So you got when you specify a cell in Excel, you got to specify the column heading and the row number, right? So I could be in cell C5. That's 2-dimensional.
Right.
You got me?
Now,
in computer science, you have like here. If I have this, I have 5 rows with 3 numbers. Because the outer normally is the row. So I got 5 rows. If I was looking at an Excel worksheet, I got 5 rows of numbers, but only 3 numbers in each row. The first position is 0 sub 0. 0 column, 0 row. The second one going across would be 0 column, first row. The next one will be 0 column, second row. Then you get to the next row, it'll be 1, 0.
Yeah.
First column, 0 row. First row, 0 column. So you do row first in computer science. And you understand? And the very last row would be 4, 0, 4, 1, 4, 2. Right? So that's how that works in computer science. So that's 2-dimensional. Nested loops. So you can have a loop, but then you can have other loops within that loop, and they will perform X number of times. Well, perform as many times as the outer loop perform. You perform it to complete, go back out, come back, perform it to complete, go out, come back, perform it to completion. Yeah, each time. All right? Now, your assignments. I know I gave you something where you got to just type, but what I want to do, I want to show you. Well, I gave you and I gave them to you because I looked at it and I saw I got help videos on the SYL site. If you go to it, you can see those how-to videos. But to create a data file in online GDB, you just simply click on this file here, and then I could create a file name, say input.dat. All right, that's an extent. The .dat is an extension. Files don't normally, well, most files have extensions. That's how you categorize them. .jpg, that's a graphic file. .docx, docx, or doc, normally that's your Word document files. .ppt, that's PowerPoint file. So you know what I'm saying? You got different extensions. .exe, executable files. So files have extensions. Data files, you don't necessarily have to have an extension, but if you have one, you have to specify that file name. Now, with data files, like we was talking about, say I put in data in here. I can put in, say I'm gonna do string right now. I'll just do string data. I'll just say Tim, or if I could type, Tim, Bill, John, Mary, what happened? Mary and 1, 2, 3, say Jill. All right, so that's 5 names, right? So what happens is with this, all right, I'll take this out. What I can do, I can read that data from that file and do whatever I need to do with it once I grab it. It's kind of like inputting from the keyboard. You know, you're reading in data, all right? But before I do that, I have to load this header file, #include fstream, all right? Got to load that file, all right? Now, once I do that, I have to determine whether or not the file that I'm looking at or reading will be input or output. I know it's an input file because I'm reading from it. So I have to do ifstream, and now I have to give it an object, okay? Just like like defining it, like when I define a variable or declare a variable. So I say ifstream in data. Oh, if I could type. Now, in data gonna reference my input. Anytime I want to do a CN for my data, or if I'm thinking I want to do a CN, I cannot. I have to do in data because in data is the ifstream object. So now, once I do that, okay, let's see, I can do int main, all right? Then I can do, I think I have to put out, I can do in data dot open. Any file that you use, just like when you're on your computer, before you can use a Word document, you have to do what? Open it, right? So just like on the computer, before I can have access to that file, I have to make sure I can what? Open it. Because sometimes I might be trying to open up a file in a restricted area. I might be trying to open up a file that have restrictions on it where I can't read it or whatever. So I have to be able to open it so that I can read it. So I do open, and then now here is the important part. You can put a path to where that file is located. The file could be on your hard drive, C:/ whatever, or in a folder somewhere on your hard drive. The file could be on an external drive or jump drive, whatever, or it could be in a location somewhere else. But working with online GDB, I know it's all should be in the same environment. So all I need to type is what? Input that. And I know that because what? This is my file name. So I'm opening this file using this object so that I can read the data. Everybody got that? Now, I need to put my semicolon. And I need to put my curly braces. Okay. All right. So now I've opened the file. Once I open the file, now I can do CN or what? Why? Let me do a for. I have 5 names, so I'll do for int, right? X equals 0, x less than 5, x plus plus. And I don't need the curly braces, but I'll just put them. And now I'll do what? Cn, well first of all, I gotta create a variable. I'd have to do string name, okay? If I do Cn name, where am I getting name from?
It's the string, wouldn't it?
Where am I getting it from? Cn allows me, where does Cn allow me to input data from? The keyboard.
The user, yeah.
Right. So remember I told you I have to use my object in data. You understand? Remember in data was the what? The file stream object. So anytime I want to read from that file, I have to use that string object, right? Now, I read in the name. Now, being that I don't have an array, I could use an array, but it might confuse you, all right? I could do this. I could do name sub 10, all right? Now, what that means is name can have how many different names in it?
10.
10 names in it, right? Now, what that also means is that I can read in all of the names and then do another process to write them out. But if I don't do an array, I have to read the names in and print them out as I read them, because what? Each time I read, I'm gonna overwrite what? Overwrite name.
Name, yeah.
If I don't use an array, right? So, and then if I use an array here, name will, I always have to reference a subscript with name, all right? So I'll take it off for now so I won't confuse you. So I'll read in name, okay? And then I'm gonna do a C out. If I can do C out, name and name. All right. So each time we go through the loop, we're gonna print out the name. So let's run it. I think I got this in the right place. When I run it, I don't have my look what happens. So now what? You're looking at computer science kind of a little differently. Huh? So rather than what? Me write code to where people are inputting stuff, I can write code to where what? I'm pulling data from a file. And that's one reason why we have gotten bombarded with junk mail, because people sell data. You know what I'm saying? Like these people at the mall, they collect it. Oh, sign up for this. Oh, it's no charge, just sign up for this. But what you're doing is you add your name to a list, right? You're giving your name, your zip code, telephone number, all that. So all of a sudden now, here you're getting floods of what? Junk mail, because what? All these people got to do, take those files, throw them into a labeler, like say, create labels using your information and mass print on stock cards and then just bring them to the post office, right? If they get 10 out of 1,000 little postcards don't cost them much or nothing. But to pay a representative to go to different people to do, or pay for advertising on TV and whatever, that's a lot of money. But to do it this way, they saving a whole lot of money. All right. So now I read in name. Now check this out, Mr. Marlon. Now watch this. I'll do a space and I'll say 3 point whatever, 4.0, 2 point. Now, what have I just done? I've added something to my input file, right? Now, this is the thing. If I try to run my program using this data file, what's going to happen?
It's gonna run the name as the first spot. The second spot's gonna be the number because it's reading from left to right, and then it's gonna go down to Bill.
Correct. Yeah. It'll print Tim, 3.82, Bill, 4.0, and John. Everybody understand that? Because it'll take this as a string, space, this is the next string, space, this is the next string, space, this is the next string, space, that is the next string. So I'm gonna run it just so you can see. You understand? See what happens. Tim, 3.82 as the second string. So you as a programmer, and remember we talked about how companies normally what? They delegate different portions of a project to different people, correct? So you as a programmer, if you writing code that's going to be reading from a data file, and then we have a team that's working on the data file and what's all need to be collected, y'all need to be what? Closely working together to know how that data is collected, in what fashion it's going to be collected, etc. All right? So you see how the teams have to work together. You can't just go off the cuff and say, well, I'm just going on and write a program, whatever. No, you have to, everybody have to be in tune. Everybody have to know what's going on. So now, for me to fix this, all right, I would have to go to the program, and now what? I'm reading the name, but then I want to say what? I'll say float, right? And I can't say int. Why can't I say int, class? Because if I say int, all of a sudden it's going to pull in Tim, all right, for the name, but then the int part is going to pull in 3. You got me? So you see, all those things we talked about earlier when we was inputting from the keyboard, you got to take those same practices and remember those so that you can not run into all these problems later on in the road. All right, so we'll go back to here and we'll say float and we'll say GPA, all right, semicolon. So now I have to read in based upon how my data file is, and my data file got name, GPA, name, GPA, name, GPA, name, GPA. So comma, GPA. Everybody understand that? Now I could have did in data name, semicolon, in data GPA, semicolon, same difference, right? So now I'll print out the name. Then what I'll do now, I'll do and I'll do a /T, and then I'll do GPA, and then I'll say, okay, all right. Now, let's run it, all right? And what now we should get Tim, 3.82, Bill, 4.0, John, whatever, right? So let's run it. See what I'm saying? Now, the 4 came out to 4, didn't come out to 4.0 because we didn't load what header file and use what? Our man IP, and then the what? Set precision fix, set precision 2, right? Remember? All right. So now, if I further want to add something to this data file, say I add whatever. Right? Oh, if I could type. Now, what data type is this? That will be string, right? So again, we going back, and what we have to do here, what happened? What's going on with this? Why is this in my way? All right, so what I have to do, string here, and then I'll just say class or whatever variable. Now, when I do that, now I have to what? Read in. So see, I'm just building on it. I could have wrote the data file and said, okay, I got this data type, this data type, this data type. And notice what? Everything is just separated by a what? A space, right? It's just separated by a space, all right? And then so I'll print the GPA, and then now I'll print the classification. All right. So now I'll run it, and we should get all three. Oh, I got error. Oh, man, class is a reserved word. Yeah, I forgot about that. Because class, when you get in the 194, they got structures and classes. All right. All right. So you see here, being that we didn't use our column width or whatever, it pushed it. This was over some. But notice classification, freshman, junior, whatever. You see that? So that's somewhat how data is actually read from a file. Now we can even write this data to another file if we wanted to. All right. How's that done? I don't know why I got this thing on the screen. Freshman. Okay. All right. So I could write data to a file. Now, one thing I didn't do my housekeeping. Normally, with housekeeping, when you open a file, you want to close it. So I'll do in data.close and that. So now I've closed the file. Because when you're working in industry or wherever, when you grab a file and you open it, you restrict other people from writing to it or whatever, so that can cause issues. So when you write code, you want to do your housekeeping. You open it, you do whatever you have to do with it. When you finish, you close it out. All right. So let's create. Well, we don't have to create an output file. The program, the way we code it, will create an output file. Now watch this. I'll say, okay, IF stream is for input. OF stream is for an output file. Now, I'll do OF stream. I have to give what? My object. So I'll say out data. So now, rather than me using cout to output information, I must use what? Out data. Right, out data. Correct. So now, just like I open an input file, I need to open my output file, right? So I'll do out data dot open. Now here is where you as the programmer have some flexibility. You can name the file that you want to create and store that data in. All right. So you can say I want it to be called output file. Okay. And you can say output file dot dat, output file dot txt, output file. You call it any valid name, Could have numbers in it. You could say you could call it 1, 2, 3, because this is not dealing with C++ variable names. This is dealing with Linux, Unix, and Windows operating system file scheme. All right. So I'll call it output of file. Now, put my semicolon. So where I have cout, now I need to do what? Out data. And I'm finished. All right. But what I'm going to do here, I'm going to change. I ran it. Okay, wait. In data. Oh, I forgot my N. All right. No. Okay. Well, I didn't want to run it. I'm going to go back to this here, and I'm going to put 4 point. I'll just do that. So now, let's go back to the file itself. So what did I do? Rather than me do cout, I did what?
Out data.
Out data. Now, normally and then I need to close it. All right, I'll close it. Output, what I called it? Oh, yeah, out data. Out data dot close. All right. Now, normally what students, well, not say students, a good practice to do, you could do cout. Completed. All right. That's so you know that it finished. All right. And I'm going to show you why. When I run it this time, watch what happened to the screen. What I got on the screen?
Just process as completed.
Right, that's all I got. But look here, it automatically created a what? Output underscore file. You understand? Yeah. It automatically created that file and what? Name, Tim, GPA 3.82, classification freshman. Name, Bill, GPA. You understand? So you didn't even have to write that. Your program processed it and took the data from NDAT, which was just the raw data, and then output it in a format to where it would have been outputted to the screen. So that's file. And I would tell you, I would learn this and I would learn how to read data, do this, because being in the age of the internet, the web, once you learn how to manipulate data and files, man, your world is open. I mean, you're just open to a whole lot. You start developing your web pages, websites. You can download, store data, have files and dump data in and do whatever. It just makes it a whole lot easier, knowing how to retrieve it and storing it, whatever. So like I say, learning this would be good, a good practice. But like I say, I gave you those assignments. The assignments basically you're just writing the code basically like it is. All right. But this is the file storage. It tells you about the different type files, image files, spreadsheet files, game files, web browsers, the classes of files, how data is actually stored. Data is circularly stored on a computer, on a disk, all right, where it's random access. Because what? Previously, well, on tape, data is stored sequentially, all right? Like the cassette tape. How many people have ever had experience with cassette tapes? If you at the beginning of the cassette tape and you wanted to access song number 7, you'd have to do what? Fast forward all the way through every last song to get to song number 7. But sequentially, like when you have information on a disc, and like say CDs or whatnot, you can go from track 1 to track 7 or whatever randomly, right? Because it randomly accesses that information, all right? Which is quick. Random access is quicker. But most time big companies store data on tape because it's cheaper. They put it on tape and then store it. Now they got the cloud, so that's something totally different too. All right. The file access method, which we talked about. You got, where you actually inputting the data, the F stream, IF stream, or OF stream. IF stream, your input, OF stream, output. The file object, we talked about that, with the IF stream, the name of the object, OF stream, the name of the object. You have to have F stream header file loaded, all right? All right, here, look, we talked about having to have the pound include set up. OF stream if you want to write out data, IF stream if you want to read data. Now, this F stream, and you'll learn that in the next class. You can define an object as F stream and then use some flags to determine whether it's used for input or output, or input and output. But that's a little more advanced programming, but you'll learn that, all right? So creating a file, huh?
No, I was just saying, right.
Okay, then creating a file object and opening a file. We did that. Look, IF stream, whatever that object name. You, the programmer, creating this object name, whatever that name is. Notice this F is capitalized, so it has to be used with that capital F all the time. When you close and doing housekeeping, this input file dot close and no argument. All right. So this is how you would actually open a file to be used for input, and we did that in the program. All right. Opening it for output, same way. But what they did was, all right, you open it with the object, and then what? You specify the name of the file you want it to be. All right. Even though here you specify the name here of the input file, but before that, you needed to know what that input file name was already. If you were gonna create it, you had to make sure you created it with that name. All right. So it's a difference. The output file will automatically be created. Now here, remember I told you you can have a file located somewhere on your computer. Notice what they did. Why they use the double backslash?
To help indicate of different folders.
Right, but remember that's an escape sequence. Remember, slash is just what? One slash.
Okay.
Right? Remember we talked about the this was in 192. When I gave y'all a program to write out / BRCC asterisk whatever, backslash, whatever. Remember, and you have to write it exactly like I gave it. So,
I think I do.
Right. Anytime in these double quotes, a backslash one time is just a single you're looking for N or T or A or whatever. 2 backslashes is nullified to 1. So that's why it's C:\\, data, inventory, .txt. So this is where that file should be located. So when this program runs this statement, it's looking for a folder on the C drive, starting at the root, looking for data, a folder named data, and then under that folder, it's looking for a file named inventory.txt to grab the data. So that's what that's saying. All right. This one here, this just saying, okay, I'm opening up a file. All right. The object is input file, and it is in the default location that I know of, and the file name is customs.txt. All right. And this the same thing, OF stream, whatever. See, what they did was, what I did it, we did 2 statements. We did this and we did this, right? What they did it all as one. IF stream, the object, and then the file name. OF stream, the object, and the file name. So it's just a different way of coding, all right? So you could code with having those 2 lines, or you could put them all in one, all right? So here, like I say, do your housekeeping. Input file, close, and no arguments, and semicolon. Any file you open, close it. Make sure you close it. Then writing data to a file, which we did, and that's a program. You can't use the cout. You got to use what? The object, whatever that output object is, out file, and then this will go to the program. Now, watch this. Let's go back here. It doesn't have to be the variable, all right? It could be anything you want to write. So like here, I'm gonna copy this statement here, all right? Copy.
Mr. Sylvester, how much time do you have left?
Oh, why? I don't have no time. What, y'all got to, I know y'all got to go. Man, I'm gonna finish this.
It's actually because I remember last time my intro to business teacher, she was on a time limit, so I was wondering if it was
I don't have no time limit. No. No, I don't really have time. You know, I just,
If you got to bounce, you could watch the stream afterwards.
Right, yeah. Right, now look, what's gonna happen here, if you look at this, what's gonna happen? It's gonna complete this, then it's gonna send this to the file also, and then it's gonna print to the screen too. So it's doing it twice. I'll just do /n. All right.
Or like that could be like somebody's like name and initials to show like who.
Right, correct. Who actually did it. But what I'm showing you, rather than just outputting process as completed to the screen, you can do what? Also to the file. You understand? So this one gonna send it to the file, and this gonna send it to the screen. So when I run it, now this is another thing. The way I open this out data, this output file, every time I run this program, it's gonna overwrite the existing one. If out file exists, it's gonna overwrite it. And I'll show you. I'm gonna run it. But there's a way to append, but that's dealing with the flags. So now watch when I click it. Oh no, it didn't finish. Let's see. Did it run? Did it run?
Will it input even though you closed that?
Yeah, it should still get. Oh, there you go. There you go. I didn't run it apparently. And now what? Where's?
Because I think you closed the file out.
Oh,
and then,
before you're right. That is true. You're right. Because once I close the file, I can what? Access it. Correct?
Yes, sir.
Yeah. Once it's closed, it can't be accessed. Right. So yeah. Right. So when I run it, okay. And then when I view it, see, process completed. And you could always what? Take this line out. You could open this in a text. You could open these files. You could open in a text file because we did them with text. You could also deal with binary. You can have your files in binary format. But what happens is you could take this out and then still use this as a file, as a label, whatever, label, whatever. I read those label 1, 2, whatever. All right. Okay. Now, okay. So that's dealing with the output file. So what they did here, they just say out file in double quote Bach, out file Beethoven, out file Mozart, out file Schubert. All right, Schubert. So they just took information that they wanted to output and just output it to the screen. All right. And look, this would be the output file. All right. Now, in this one, same thing. Okay, what we got? OF stream, but you got what? F stream here, OF stream, out file. Out file dot open. Now, what's the file name? Demo file.txt. That's the file that the information will be stored in. So Bach, Beethoven, Mozart, and Schubert will be put in that file called demo file. All right. Okay, but what they saying there? Oh, the only difference is this one they had \n in this one, and in this one they didn't have the \n. So it's just like it's gonna be on the screen. That's how it will be in the file, exactly the same way. All right, and like I said, numbers. You saw that where we had numbers and whatever. Same thing can go to an output file. Now you can interchange. I could say, "See out, please enter a number," right? So, because what? You need to communicate with the user. But then what? Out file, whatever. See out, please do whatever. You got what I'm saying? And see in, whatever. And then, so you can go back and forth with see in, see out, and the data in files and out files, right? There's no limit or whatever to that. Whenever you use the object of input, it's going to read from the file. Whenever you see in, it's going to read from the screen. Whenever you use the out file object, you can write to the file. Whenever you use see out, it'll write to the screen. And at any time, you can go back and forth and do it, so it doesn't matter. All right. What else? What this program doing? Let's see. All right. So an example that reads a string. We read in a string, right? We already read in the string. So it read the string from the keyboard. Well, we didn't read from the keyboard, but we can do that. We can read from the keyboard and write it. Let's go back to our program. So in this program, I'd have to modify it a little bit. Let me save this one. Why does it save here? Okay, I'll save. I don't want that. I'll save this one. All right. It's saved. All right. So what I can do where I am doing what? I don't want to end data. I could do what? CN. I'll just do CN. All right. And I don't need, I could leave that as that. It just ain't going to be used. So I could say C out, because when you do CN, you got to tell them enter name. right? So when I run this, oh, what did I do? Semicolon. All right, so run that. So now my data coming from the screen. So what I can put in Timothy, GPA, say sophomore. I'll just do that. Name, Anthony, and what? essay. Let's say what another name?
Steve.
Okay, I'll go Steve next.
Mr.
Yeah.
Sylvester, is something wrong with your mic? Because it's just deep now.
What you mean deep?
I don't know if it's on my end, but your voice just sounds deeper than, well, probably because of Zoom. I don't know
Yeah,
why
but
it's happening.
I didn't change anything. It's still deeper.
No, you're good now. Yeah, it probably is my end. It's on my
Oh,
end.
well, I think I was talking low because I was inputting names. So I wasn't talking out loud. I was kind of like talking to myself. That what you're talking about?
I think so. Yeah, that's probably it. Because it just always.
Yeah, I was like mumbling. Yeah. Okay. Like they doing like this, like whatever. Yeah. Yeah, I was.
Is it already too late to send a roll, by the way, or because
I'll have to add you. And one more name. What? And like I said, I messed up, but watch. See what happened? Watch when we open our output file. See what happened? Timothy, whatever, Anthony. So I could input them from the keyboard and then output them from whatever. So you interchangeably, you can do it interchangeably. It doesn't matter, right? It does not matter. All right. So but like I say, this is a good thing to learn, learning to use these files. All right. Reading data from a file. We've read data from a file. All right. The read position. All right. What happens, and we talked about that, it'll read the first name, okay? Then it'll read the next name, then it'll read the next. When you're reading from that file, normally that's a space. Well, not really. When we go here, in our data file, yeah, that's a new line at the end. I'm reading this, new line. This, new line. This, new line. But they only had the names. So when we just had names, it was Tim, new line, Bill, new line, John, new line, Mary, new line, Jill, new line. And that's all it's saying. That's how the data is set up. All right. And really, we look at it that it's stored circular on disk, but we really looking at it reading the data basically in this fashion. I'm reading in the first name, new line. Reading in the next, new line. Reading in the next, new line. All right? All right. And when it writes it, same thing. It writes it basically back out the same way. All right? So now, this is the thing. And what they show in the read position, the first time you read, it reads the name. All right? Then when it loop back, let's look at ours because ours are a little different. When it reads, it's gonna read Tim, the number, and then the class. All right. Then when it come back to read, the read position is at the next record. It's gonna read Bill, this number, and then this string. The read position is now here. So you see how it reads every individual line. All right. It goes down. Now there is a way to randomly read information, but that's advanced too. You know, you can randomly, you can insert and do all that too, you know, into a file. So there's a lot of different things you can do with programming languages. All right. So it's just showing you how it reads the first, Then the marker becomes here, read that one. It becomes here, read that one. All right. So, and like I said, we read in numbers and we read in string. All right. And we use the loop to do it from the very jump. So it said what? Using the loop. We did the loop and what? See out, enter the sales for the day. We enter the sales and then what? They write in the sales. What we did, we read it in and we wrote it out. But then what? The first time we did it, we read it in. We just read it in and output it to the screen. So all these programs just showing you how it works. And basically what? F stream, that's the load. That's the header file. OF stream out file, that's the object. Now we don't have any input file, so what? The data gonna come from input. Where we writing the data, we opening a file called sales.txt. All right. Then we're doing what? Using our object out file to actually output sales to the file. And once we complete it, we closing our file. All right. Simple as that. All right. Detecting the end of file. All right. There's ways to detect the end of file. Now, what happens with that is, look here, while in file. Remember we talked about our Boolean value where it's anything other than what? 0, correct? Basically, this is the same way. This says while in file. Long as there's something to read, I'm gonna read it. Now, the thing is, this is good when you get a file. Say you're working at a company and you got a file that you gotta process. You don't know how many records in the file. So what? You know the different variables that you gotta read. You don't know how many records. So you can do what? While in file, right? Read it, right? And then what you're doing, you're inputting the information into number. So what's happening, you know that what? You're just reading in what? Number. One number going into the next record, reading in the next number, next record going in, reading the next number, reading the next number, right? So that's what's happening. So you can use that to say go to the end of the file without having it, because you could get another record a day later or 2 days later, and the record is shrunk, or it could have increased. So that's one way of doing it in many different ways. All right. Now, this is something good to use too. If you had questions about whether or not your data file exists or either the compiler can find it, what you can do, take this little code here. All right. Where it is. Yeah. Here. See here? What happens is, but you got to make sure you can't just copy the code. You got to know what? My input file object is input file. Whatever yours is, you'd have to match it to that. So, and then look, input file, you're opening, but then to what? You got to make sure the file name that you're looking for is this particular file. So you understand, you can't just copy code and say, oh, they said this code would do X, Y, Z. You got to make sure you match it to what you're doing. So if your file name is called input file or input.dat, you would put that right here, all right? And then what happened is saying if in file. So this asking if it finds it. If it doesn't find it, it'll say okay. Well, if it does, if it exists, it'll do this. It'll go ahead on and perform whatever read you have to read. But if it doesn't exist, see out error opening file. So now you got what? You got a flag saying it cannot open it. You're not guessing saying, man, why my data is not outputting? What's going on? And simple fact is it cannot find the file. File is not open or can't be found in the location that you're looking for it. All right. So that's a good thing to use in your program when you're writing code. All right. Or what really reading from a data file. All right. Now, this is a shorter version. All right. IF stream, your object. You're opening up the file using your object. But look, remember the other file, the file name was what? Bad something. Bad list of numbers.txt. In this one, is looking for the file name customers.txt. All right. So this one say if input file and fail is a function. All right. If it fails, print out error file. File cannot be found or file not open. Otherwise, you can't have all your data or whatever you're gonna process. All right. So they give you just different options. All right. Now, this is also a technique you can use if you are writing code to where many times you might have various file names that you need to work with. What you can do, you could write the code where the user inputs the file name. Right? So this gives an example. So look here. All right. You still have what? Fstream, all right, as your header file. Then your IF stream input file, which is your object. But look what it says here. Enter the file name that you wish to input data from. Then you do cin file name. Whatever you input, look here. It says what? Input file dot open. No double quotes. Whatever that file name is. All right. So you typed it in. We could have typed in out.dat. Then it would use whatever that file variable. It'll have it here, but it knows it represents file.dat. Out.dat. So what happens is you're checking your object to see if it exists. All right. And what? Then while in file, you're gonna just read. All right. Otherwise, you got you're closed. But otherwise, you had an error. It could not find the file. All right. But you're kind of making it to where they type it in. So the next time it might be another file. You might have 3 or 4 files, same formats, or 3 different companies sent you information. I don't want to have to keep changing the name of the file for each company because I can't write them all in the same location with the same file name. They will overwrite. So that would be a scenario where you probably would want to use this, okay? And then you can actually process it. All right. This said using the CSTR memo function on older versions of C++. We don't have to worry about this right now because, like I say, we pretty much done moved on past the older versions of C++. All right, but it's an option for string objects. All right, so but we don't have to worry about it. All right. Breaking and continuing a loop. All right. So anytime you're in a loop, you can use the word break and it'll take you out. Remember we used the word break in switch, the switch case statements, right? Remember we had case whatever, do whatever, case whatever, well break, case whatever, break, case whatever, do whatever, break. So the break, you can break out of any if statement if at any time. Once it hits that statement, it kicks out though. Because if you look at this says while count is less than 10, while count plus plus is less than 10. So what? At the first time it's 0, right? Because it doesn't add 1 until what? It leaves that line. So 0 less than 10, yes. All right? See out 0. If count is equal to 5. So how many times did we perform this?
Just 5 times.
5 times. You got what I'm saying? So because when it gets to 5, it's gonna kick out. It will kick out. Okay. So that break will make it kick out of this what I want to say. Scope, that particular scope. It'll allow you to kick out. All right. And so this give you an example. Look, if Q or Q just break and it ends the program. All right. You don't have to say end of whatever or whatever. It's just gonna break out. All right. So that's the break. Okay. Using break in nested loops. Okay. In a nested loop, the break statement only interrupts the loop it is placed in. Remember we talked about just now, the scope. If I break out of this loop, it's gonna fall back still to that other loop and continue. Because what? This loop has to get to 5, right? So it has to get to 5. So it'll do this from 1 to 10, all right? And then it'll break out. It'll go here again, until row is is greater than or equal to 5. So it only gonna work within that scope. That's all it's saying. The continue statement. The continue statement causes the current iteration of a loop to end immediately. Okay. So when continue is encountered, all the statements in the body of the loop that appears after it are ignored, and the loop prepares for the next iteration. All right. So in a while loop, this means the program jumps to the test expression at the top. So if I got continue, like maybe in the mid part, it just go right back to the top of the loop. And again, if you got increment after that, you could probably get caught up in a continuous loop because it's continuing, it's going back without increment. So you're probably going to want to increment before you do a continue because it's going to keep going back to the very first statement in the loop. All right. So look here. Look, you got they got. So they got the plus inside again. So they got while, because if they had the plus after this, it would be a continuous loop. All right. So well, no, because the continue in the if. So here, what happens here? If test value is 4, so it's gonna start here. And it's gonna do this. Okay, it's gonna put 1. If it's that, if it's equal to 4, no, it's gonna do that. All right, it's gonna do this. It's gonna output of 1. All right. So look, it just skipped the number what? 4. So what happened? It went back here. Break does what? If I had a break here, it done what? It kicked us out of the whole scope. Continue takes us back to the iteration. So what? It printed 1, it printed 2, it printed 3. It's equal to 4, it say continue. Continue means go back to the beginning. Break would have took us out, so it would have printed 1, 2, 3, and it would have kicked us out. All right? It would have kicked us out of that scope. All right? So you got to remember that. But that's what's the kicked us out. Because we wanted to kick us out of that if, and then brought us back still. So it's pretty much the same. Now, so this is a program. So we doing this automatically. We incrementing inside of here. So we performing this, where's the break? I don't see continue. So if DVD count modulus 3 is equal to 0. So anything that's divisible by 3, is what it's going to do is going to output this and immediately start the next iteration. So once it gets to 3, it's just going to go down to this while and start the iteration. So it'll go down here. When continue. When it get to 3, it's going to kick out. But then it says DVD count less than num DVD. What's num DVD? Num DVD is inputted. Okay. How many DVDs? Okay, and being ready. All right. So what happens is it's going to divide, going to do the modulus of DVD count. Well, where's DVD count? Where's equal 1? So it's 1, 1, 2. But then when 3 divided by 3, you get 0. Then that's when they're going to continue, which kicks out here is DVD count less than number of DVDs. So if you got, 5 DVDs, it's less, it goes back. 3, if it's 3, okay, it goes back. But each time it's going to do a free DVD. Every time it's 3, you're going to get that free DVD. So that continue just allows it to start back over and get to this while. So like say if I got 6, the first 3 free DVD. And then when they hit that 3, it won't allow you to just keep continuing to enter all yes, no, whatever. Go to here and then do the next 3 and then it kicks out. So that's the continue. Can be tricky, can be whatever, because you want to make sure know what your input is and you know what's going on in here. Because when you start trying to if this and while this, you got to make sure it's doing what it's supposed to do. So you got to know how to code it. All right. So look here. If you had 6, the first 3, you get that free. When it say continue after this, it goes back to say if 6 is less than the count. Well, if count, which is 3, less than 6, yes it is. It went back and started over. All right. So that's basically it. Hopefully those programs that I give you the right, you can actually run them, can do them. But I gave you help. Let's look at one of them. Let's look at one of them. And like I said, you're just really typing it. Or is it? Is this your class? Yeah. All right. That's dealing with chapter 5. Okay, dealing with loops. But then I thought I gave those other programs. Come on. Okay, all right. So those were those 3. So, right. So here, this is the 3rd one. So looking at this one, it says using Visual Studio or online GDB, type in the following program. So I gave you the program. The issue with this assignment is following those instructions. You type in the program. Make sure you type it and get all the errors out. Remember, semicolon, parentheses, double quotes, commas, all that matters. You're going to type that program in the compiler. Then what it says is, once typed, this one allows you to write to an output file. So what's going to happen is everything going to be typed, and when you run the program, you're going to be inputting information and well, no, here's your input, a sample of the input file. I hope I don't download it yet. So here's an example of an output file, input file. So it's giving you an example as how to type it. And normally, when you see this, you're going to type Tim space 10, enter. Bill space 20, enter. John space 30, enter. Everybody understand that? So you type in the program. Once you type in the program, all right, then it says that, let's see, move this out the way. All right. You type in the program, you'll notice that the program is exactly the same minus the code added for the input file, okay? Test the program and remove any and all errors, making sure that the output is correct. Upload the completed CPP and TXT files. Also prepare a demo, you can scratch that because we're gonna be in class, all right? So the output file will be created on your computer, all right? But now if you use online GB, it's gonna be created in that session, and you can just save it, and it'll save with it. So it'll be created in that session, all right? You can view the output of a output file using Notepad, or you can even open it in Word because it's just a text file. I recommend you use Visual Studio to do this assignment so that you can view your output file. But you can still view it in online GDB also, because it's going to create it, all right? So you're going to type this file, and then you're going to run it. It's going to read from a data file and write to an output file. So this example data file, input file, and this example output file. So that's number 3. But following the procedures, because you don't type the output file. The output file will be created based on what you typed in for the execution and the data file, input file that you create, all right? Now, this one basically a program that reads from a data file and is going to output to the screen, all right? So make sure that you get all the errors out, you know how to create your input file, and then you know where to access it from. If you use online GDB, when you do the new file, it'll be already in that project. And then when you click save, it'll give you an option to give you a name to save it. And then if you logged in or whatever, it'll actually have under My Projects all of your files. So you can just simply click on that file name that you saved, and you could have all your information. All right. So in the first one, like I said, the first file was simply using I think a loop. Yeah. So this one, I told you, and this is kind of tricky now, because this is a nested loop, but we kind of looked at it. Write a C++ program using nested loops, choosing 2 of the 3 loops discussed in chapter 5. Okay, the while, the do, or the for. All right, that will. Just your outer loop. The outer loop should allow a user to, continue calculating the average of 3 numbers entered if their choice is Y. Okay. Now, what you're gonna have is you're gonna have that outer loop that's gonna perform. I forgot how many students. How many students I said? I didn't even give the number of students, huh? I'll keep reading. And the nested loop that will loop 3 times. So for a student, well, it's just one. I think one. The nested loop, you're gonna read in 3 scores. Now you're gonna have to accumulate that score. Remember? So what? You're gonna have to keep adding to that score like we did with that balance, so that you can divide and get that average. Okay, so it's gonna loop 3 times, allowing the user to input an integer value each time. Okay, note, you should calculate and output the average of the 3 numbers using the appropriate labels. Okay, after average, okay, the average should be formatted with 2 decimal places. So we should use what? Our man IP. Use the labels in the example below for your output. All right. Oh yeah, so I didn't tell you how many because you're gonna do yes or no. So what happens is, what you're gonna do is using a label. You're gonna have a loop, right? But then inside that loop, you're gonna have another loop, and that inner loop gonna say input a number, you input it, and you add it. Input the next number, you input it, you add it. Input the next number, you input it, you add it. Once you completed that, the inputting those 3, you're gonna fall out that loop, but you can still be inside of the outer loop, and then you're gonna calculate and print the average. Then that should take you back to actual type in Y to calculate another average. You're gonna put in Y or any other character. If you put in Y, it should take you back in, then take you into the loop and allow you to do 3 more. Okay, everybody got that? And then, like I say, you'll repeat that until you put in any other character than Y, and it should kick out. All right, any questions? Questions?
No, I'm pretty much good.
All right, because remember, now you got to,
at least.
Right, I'm gonna show you. Remember, well, okay, so I did that loop, and like I said, I'll do for, all right, and what I'm trying to show you is, well, I'm gonna put this out here. What I want to show you is I can do anything prior to this inner loop. All right, I could do anything prior to or after that inner loop, but it's still a part of that what? Outer loop. Everybody understand that? This loop is just nested in between. So if I wanted to print out the average, I wouldn't print out the average in this inner loop. I'd fall out of the loop, print out the average, then go back up and check for my choice, or either have a do and check for my choice. And if it's Y, go back up, fall in this loop, calculate, print out average, ask the question, go back to the loop. You understand what I'm saying? So you got everything in between here and everything between here. You can put code in there. You're not limited to say, oh, I put the curly brace. I didn't think I could put code before a for loop within a for loop. Oh, you can. I can put anything in between these two curly braces. All it's saying is this for loop, when it ends, I can do something here. I could output today is Friday or today is whatever. What'll happen is it'll perform this, get out, today is Friday. Go back, enter it, perform this, today is Friday. Perform this, today is Friday. So you understand? So you can put data here and here. Now you can't do this now. If I put data here, then I'm nullifying my for loop to only execute what? Just this one statement here. So you gotta watch that. All right. So I just want to make that clear. Okay. Anybody have any questions? Like I say, look through the chapters or whatever, and work on your program. Now, what I'll do is, y'all want to take the test this week or next week?
This maybe next week, I think.
Okay, because what I'm looking at is, okay, I could give the test today and do whatever, but I could give it next week. And then we'll start on the next chapter, and then we could probably have a little small test, and then we have our final. Now, what I'm gonna do also on that next week, I'm gonna open up the tests and quizzes for those makeup and stuff. You know, that extra attempt.
Yeah.
And the practice final. I'll open that up for this week here. But remind me also. You know what I'm saying?
Okay.
Not this week, but remind me, because I don't want to forget. All right?
Yes, sir.
Okay. All right. Any other questions? Questions?
No,
So
I think that's it for me.
Okay, so I'll let y'all work on the programs and try to get them and try to understand them. Like I say, try to work on them. Don't just work on them one time and say, oh, well, whatever. Try to work on them. Try to get it. Because once you get it, once you know it, man, it's telling you, it's going to help a whole lot. All right?
Right.
Any
Yes, sir.
questions? Any questions? All right. So, okay. So, like I say, you always can email me or whatever. But I'll see y'all on next class period.
Oh, Sylvester?
Yeah.
Okay, I'm back on. I have a question about the test yesterday.
Who is that, Mr. Who?
Masterson.
Masterson, what's up?
Was it supposed to be due at noon?
What test?
Test 4.
Oh, test 4.
Oh,
Been
it
over.
was it was due at noon at 11:59 a.m.
Because the rest of the assignments were due at midnight, and I thought the test was due at midnight.
Right, but normally, if I do it, see, how would I say it? This is what I normally would do. I would stop it, cause see, I never like to let my tests run through the class period, because now either you're going to take the test and not come to do the class. You know what I'm saying? So I would normally say, okay, the day before class, 11:59 at night. You know what I'm saying? So, but being that it's online, I say, okay, well, I'll leave it open. So for the morning, if somebody working or whatever, they still got time to wake up in the morning and take the test, before whatever, but
it was yesterday at noon, the day before test at this class.
Right. Well, but that's normally my practice. Oh, at noon. So it was at noon yesterday?
Yesterday, yes.
Yeah, well, that's my. I would say that's on me, because normally I would say midnight. Yeah, no,
yes, sir.
On that part, yeah, that's on me.
Because the rest of the assignments were due at midnight yesterday.
Right. So let's see. No, what today is? No,
Today's the 15th. Today's 15th.
Yes.
Oh yeah, I did post test 5, but anybody who feel like taking test 5 can take it, but I'll extend it next week.
Okay.
module. Oh no, I don't need to go to. I'll go here. Previous. What happened? Module. Okay, let's see. Test. That's test 4, right?
Yes, sir.
Yeah, I think so.
Okay. Yeah, I got AM. Yeah. Okay. So what I'll do, I'll leave it open till tonight. Let's see. Let me do an edit. Yeah. I messed up on that one. And today is 15 and 11:59 p.m. Well, I'm not sure.
The bottom.
Oh, I can't see. Oh, I got this thing in the way. PM. All right. All right. So yeah, you'll be able to take it tonight, up until tonight.
Thank you.
All right. Okay. Any other questions, concerns, or whatever? All right. So like I say, I'll just open the test. Well, I'll leave it open till whatever, and I'll reopen it. Like I said, I don't like it to be open during the class time. All right. Okay.
Yes,
so
sir.
I'll see y'all on next class period.
For sure. Take care.
Good, Mr.
All
Sylvester.
right, y'all too.
All right.
All right.